Now, here's an example of a question which asks you for the molecular formula. We're told that we have an empirical formula for xylene, C4H5. Okay, it's a liquid and it has a molar mass of 106 grams per mole. They must have used a mass spectrometer to determine its molar mass. So what is the molecular formula? First step you want to take here is to find the molar mass of the empirical formula. And so we'll do that just now. So the molar mass of C4H5, okay, is equal to 4 times 12.01 grams per mole plus 5 times 1.01 grams per mole. And that works out to be 48.04 plus 5.05 grams per mole. In total, okay, so C4H5 has a mass of 53.09 grams per mole. But we know that for the molecular compound, the molar mass is 106 grams per mole. So an easy way to determine the multiplier that we'll use on the empirical formula is to divide the molar mass of the molecular formula by the molar mass of the empirical formula. So our X value is equal to 106 grams per mole divided by 53.09 grams per mole. When we divide that through, we end up finding out that it's 1.9966. We can assume that's pretty much the exact same thing as 2. Actually, if we look at the significant digits, in this question we're given 1, 2, 3 significant digits. Here 1.99, that's our last digit that we'll use, and we'll round it up because the one next to it is 6. So in fact it would be 2.00, rounded up using significant digits. So if we use that as a multiplier, our molecular formula will be C4 times 2 times the multiplier, H5 times 2, that's the multiplier, okay, is equal to C8H10. And that is the molecular formula for xylene. Here's one last example of calculating molecular formulas so that you have some more experience with them. Okay, we're going to be talking about calomel, which is a compound that was once popular medicine. It contains 84.98% mercury and 15.02% chlorine. Has a molecular mass of 472 grams per mole. And they're asking us what is its molecular empirical formula, and then it should be asking us what is its molecular formula. We'll just change the question. Okay, the truth of the matter is this was supposed to say molecular formula, but we need to find the empirical formula first before we can actually calculate the molecular formula. So we'll just go about that. And I think this will be a good opportunity for you just to have one more example in front of you of how you calculate empirical formulas. So here we go. With the calomel here, so what we're first going to do is we're going to assume we have a 100 gram sample. So for a 100 gram sample, for the mercury, we're going to have 84.98 grams of that element. For chlorine, we're going to have 15.02 grams of that material. So we can go ahead and calculate its empirical formula using those bits of data. Okay, mercury, in that 100 grams, how many moles do we have? Okay, so 84, so I can put a number of moles of Hg is equal to 84.98 grams divided by the molar mass, which we look up from the periodic table, of mercury, 200.59 grams per mole. And that works out to be 0.4236 moles. Okay, and then for chlorine, in the 100 gram sample, the number of moles of chlorine that we have is equal to 15.02 grams divided by the molar mass of chlorine, 35.45 grams per mole. Okay, and that works out to be 0.4237. Oops. 37. Okay. So the next step is to put it into empirical formula format. So it will be Hg 0.4236 and then Cl 0.4237. Divide these things by 0.4236. And that's basically going to be cancel, 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 HgCl. It's pretty much a 1-to-1 ratio. Okay, so that is our empirical formula. And from that, we can now go ahead and calculate the molecular formula using the molecular mass, 472 grams per mole. Okay, HgCl. So, the molar mass of the empirical formula, HgCl, is equal to the mass of mercury from the periodic table, (200.59 grams per mole), plus the mass of chlorine from the periodic table, okay, so the molar mass of the empirical formula in total is 200.59 plus 35.45 plus 236.04. Okay, so that's the molar mass of our empirical formula. So to calculate, and we know to calculate our X value, we're going to divide 472 grams per mole, our molecular mass, our molecular molar mass, 472 grams per mole, by our empirical formula molar mass, 236.04 grams per mole. Okay, 472 divided by 236. Equals pretty much 2. So therefore, our molecular formula is Hg2Cl2. In summary, the molar mass of our molecular compound is going to be equal to the molar mass of our empirical compound times a multiplier x, which is an integer. Okay, so the calculation that we're going to be using during our calculations is going to be, we're finding the X value, and that's always equal to the molecular mass, molar mass, divided by the empirical molar mass. Okay, hope you've enjoyed the lesson. Have a good day.